record. Yeah, because I need this recording. I'll possibly upload it in YouTube or share the direct Zoom link so that you have access to the video. Whichever way is convenient, I'll do it. So don't worry. But yes, remind me of recording the video whenever I start with the classes next time. Okay, so let me once again share my screen and let me know if it is visible now. Okay. So for people coming from material science and engineering, let me tell you, there are two frontiers of researchers. One are the experimental and experimental researchers, and the other whom you might have seen are people having mathematical modeling experience. Am I right? Now, there are plenty of folks in the IITs, professors, researchers who work on mathematical models. So what are these models especially talking about? So these are models which are based on something called as the constitutive equations. Vinod Kumar and Daya, are you familiar with these terms, constitutive equations?
No, sir.
Okay.
So
So,
little bit.
sorry?
So just a brief, just a little bit I know.
Okay. So I'll tell you, no issues. So these models, these mathematical models, like at IIT Kanpur, my friend Nilesh Gurao or Krishnan Biswas, partly they're doing, they are working, building models which are based on some equations that you have framed already. Okay, so if you talk about finite element analysis, for instance, I guess other than Anas, all of you are familiar with finite element analysis, right? Or computational fluid dynamics, FD, or molecular dynamics simulation, density functional theory, or maybe dislocation dynamics, phase field modeling. Okay, so just all of you unmute and tell me if you have heard of these models.
Yes, sir.
Okay, so all of you have at least have heard these names, right? So
Yes,
these
sir.
are models which are kind of built based on some equational framework. So here they talk about boundary conditions, many things comes in. So you have to design your own equation, you build your equation using partial differential equations and so on. So these class of models or mathematical models, which you largely say people from chemistry, material science, physics, metallurgy, chemical engineering, they do, are these what do you call as constitutive equation models, or they're more popularly called as physics-based models. I'll write down these models are called as physics model or physics-based models. Now, I'll tell you there are pros and cons using these models. In industry, somehow, these models have not been very much accepted or appreciated in industries like our, who are into continuous production. Possibly these kind of miniature models or localized models, I would say, are specific to a very narrow regime. They cannot be expanded or extended across a larger length scale, or it cannot be simulated over, say, a heterogeneous microstructure. So a lot of problems are involved with these models. So people from especially electrical engineering, for example, or mechanical engineering, not the materials part of the mechanical engineering, because mechanical engineering itself is a very wide area. So there are people using, working on control system, electrical power design in case of electrical engineering, load monitoring. There are plenty of applications where they are making use of huge, big volume of data, or what we call as a big data. So in those kind of what you call as large scale um, um, databases, or where you have a lot of data involved, you typically can't go with this physics-based models, which are very localized. So people from these community, especially electrical engineering, mechanical engineering, a lot of civil engineers also do, among the engineering I'm talking about, and of course, manufacturing. They rely mostly on large volume of data. Okay, so the larger community of material science engineers or metallurgists, those who have been talking about using mathematical models, like I'm not sure if uh, uh, I mean, what's your name? The gentleman from IIT Kanpur.
Sir, Sai Kumar, sir.
Okay, Sai. So Sai, I don't know if you know Professor Deepak Mazumdar. Have you heard about
Hi,
him?
sir.
So Deepak
Hi, sir. I
Mazumdar,
didn't make it.
yeah. So then Professor Singh, okay, Amrinder Singh, they are people from these physics-based models.
No.
Okay, they don't use the, so that was the scene. Like people from these engineering communities have used data science techniques for a long time. They used to call these as forecasting models. Even, they had many names. Okay, but possibly these all got assembled under the umbrella of data science much later. But the physics-based models, I was telling you, largely considers the mechanisms, or take into account the mechanism which occur at the micro level or localized level. Okay, so we are not going into physics-based model. Our idea is to move on towards looking into how big data can be, what are the different models that can be used. Now, when I use the word model, a model is something which can be established mathematically or statistically to make some kind of prediction. That's the most rudimentary definition of models. Okay. Any kind of prediction or forecasting based on some mathematical equations which can be written down through equations, which can be physics-based equation or statistical equation. Okay, so those are typically called as models. Okay, now in material science, there are a group of people who are claiming to be working in the front of AI, ML, data science. Like Krishanu often tells, I have a good number of students who are actually working on AI, which I agree partly because uh, these people from material science engineering department, not just in IIT Kanpur, even in IIT Bombay, Kharagpur, I'm only talking about the people from this materials and metallurgy engineering community. They are largely working on very niche and specific area, which is mostly neural network models. Okay, so neural network models are class of AI algorithms, one degree above the conventional data science models. But the flaw with applying this, neural network model is that they don't have much of expertise in understanding the statistical behavior of the model. They have not uh, possibly started from the scratch of you can say, understanding the statistics behind how the statistics or the statistical significance of this model is something that they fail to understand because they have not cultured that. So it's only a very narrow domain where people in materials metallurgy community are working, but they cannot be kind of called to be data scientists or AI/ML specialists because all they're doing is they are not even many I know they're not even building the models. The models are built by possibly faculty or students from mathematics department or computer science department. They are borrowing those models, applying those onto, I mean, their experimental data there. Okay, so and this is something that they are doing because I have interacted with faculty members from different IITs, and that is what I say. They have kind of lacuna to really go in deep into the statistical understanding behind the working of the data science models. So possibly I would say they are doing it half-heartedly. Daya, are you getting my point? What I'm trying to mean here?
Yes, sir.
And do you agree?
Actually, that's happened in our department also. Like, I know.
Yes.
Sorry, sir.
Did you agree to what I said?
I can't get you, sir.
Okay, I asked, do you agree to what I said just now? My
Yes, sir.
remarks
Yes.
about the material science community who claim to be working in the area of AI data science in true sense, and you also have experience. Most people are talking about neural network.
Yes,
But
sir.
if I give them, suppose, if I ask them, say, I make some classifier, neural network models are classifiers, right? So, Prashant, I guess you are familiar with these things partly, like you can do some kind of classification regression using different NNs. Okay, convolutional neural network, artificial neural network. Okay, there are plenty of this. Okay, now the point is, suppose I give you, say, I generated a model based on knife-based classifiers or k-nearest neighbor, and you come up with a model using classical neural network model. Okay. Now, if I ask, prove that your model is the best. Okay. These guys, these material science engineers who claim to be working on AI, cannot prove it statistically. And to prove statistically, there are techniques which we call as hypothesis testing. How many of you have heard this word hypothesis testing?
I heard about hypothesis testing, sir, but in detail, I don't know about that.
Okay. And Anas, I guess you know about hypothesis testing.
Yes,
At least
sir.
you have
I
heard
know
this word.
about it. Yes, sir. I know
And
about it.
how about Prashant and Vinod?
I heard about it, sir, but exactly I don't know like how it works.
Okay. Okay. No issues. No issues. So this was coming to Prashant, what you were possibly looking at, I am now understanding you have various microstructures, and what you are going to do at the end is possibly apply those on a neural network model. And the best microstructure classification is done by something called as a convolutional neural network. Okay, you are familiar with this name, CNN.
Yes, sir.
Okay, and I'm sure you're going to, at the end, you're going to use this. But let me ask you, to all of you here present, including Prashant also, how many of you wish to start a career in data science and AI? Give me a very frank answer.
I want to pursue.
Sir, and I am also interested. Yes.
So then you have to think from the point of, a data scientist and AI/ML specialist. Okay, just being narrow with some materials engineering problem, and that too, uh, because okay, now I'll come back to what I was my interest was into. So so I have my screen is visible, right? Okay. So this was I told you about how material science engineers are trying to use data science models, and not just data science model, they are specific to neural network models, and some are using the other established models also. But largely they are, as I said, are working on the neural network model. So that is not going to give you much of opportunity if you're talking in terms of opportunity in future. Just working on just a few NN models for making some image classification or property identification will not help you much. But so that was how I also have started thinking. Now, back in my PhD, I used to some extent, the multiple linear regression model, which is so when you say about, let me come to the data science community. So data science community is a very large community. You have people who are working on algorithms, algorithm building. There are people who manages data. Okay, that means how to collect the data, because data collection is very challenging. And then you have to do a lot of data preparation techniques. Data preparation. So which data to keep, which data to scrap out. So all these things are essentially done by the data managers. Okay. So, and then there are called data pipeline engineers. So this is just a small introduction. And there are, of course, very important member in this data science community. Can anybody guess who can be this last person I'm trying to? There can be 6, 7 more people also, but they are essentially the principal pillar of the data science community. Can just somebody make a guess who can be this last person?
Big data
Statisticians?
Sorry?
statistician.
Statisticians?
But they come into that algorithm building. Okay, I'll tell you. Some of you may be familiar with this word. It's called SME, meaning subject matter expert. Okay, so subject matter expert is also a very important, a member of that community, without whom you make a algorithm, build a statistical algorithm, statistical model, but eventually what you are going to predict is not known to you. Who will inform you is a subject matter expert. He will come to you with a problem, and he is the one to actually validate whatever you have developed or generated as a model, if it is going to practically be implemented or not. So these all comes under the scope of subject matter expert. Now, coming to my thing. So I have always been an experimental researcher, as I've told you. I'll take another 10 minutes to finish my, not even 10 minutes, maybe I'll try to finish it up in the next 5 minutes, and then we start with our main program. Okay. So I have been all throughout in the field of experimental materials science. As I told you, my expertise lies in microstructure process control. I'm a microscopist. I do TEM investigation, that means TEM diffraction pattern study, electron backscatter diffraction study, all these things were in my scope, or still in my scope. So after doing my PhD from IIT Bombay, I moved to UK at Imperial College for doing my postdoc. And then following that, I moved to Canada for doing my second postdoc. I came back to India, and then I was working as a faculty member for a short stint at Manipal University. And then I made a switch to industry with the R&D of Bharat Forge. I guess all people here present are familiar with this name.
Yes, sir.
See, now at Bharat Forge, when I joined initially, so AI ML data science is something that I have started working on back in my Manipal days, like as a faculty member. But gradually, after coming to Bharat Forge, I got exposed to different, like different data, not just the R&D metallurgical data, but data from quality control. Then you can say predictive maintenance, a lot of data. Bharat Forge itself is a super big company. So I got to see, earlier I was thinking like you people, कि मुझे so Hindi is okay with all of you, right? So मुझे भी काम इसी में ही करना है, materials engineering में microstructure study, blah 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 and so on. But after coming to industry, interacting with people from different business communities, I got kind of exposed to different business interests. Okay, and that got me a special interest to dive into this data science algorithms, not just to solve problems from materials engineering, but extend my expertise to other domains or other business domains. So typically, I am not using, though microstructure materials property is used to be my bread and butter, but I'm largely using my data science techniques in statistical process control or statistical quality control. How many of you know this term? I mean, I've heard about this term. Hello? Hello?
Yes, sir.
Sir, you are audible.
Audible,
Okay,
sir.
I'm audible. You, all of you were present in my previous seminar, okay, the last webinar that I conducted. So I'm more interested in applying this data science techniques in large process control, material selection at the factory or manufacturing level, typically not at the R&D lab levels. Okay, see, the eventually that your expertise will say, if you ask me, I'm a data scientist, say I have expertise working on different data science model. Can I work on a problem in finance? The answer is yes, I can, provided I have some kind of subject matter expertise in that area. If somebody tomorrow comes and asks, will you be working in the area of credit card fraud analytics? I won't say no, but I have to understand how the credit card data goes. Okay. So Anas was talking about understanding fraud. Okay. Looking at the data. So that is a special area which is called as the fraud analytics. Okay. So now data science, AI/ML has spread its wings into multiple other business verticals, of which the most um, widely used is market analytics. I'll come to the next slide, market analytics and e-com. And e-com. Then is what you call as retail, supply chain management. Then you have HR analytics. Then I can say, so these are from the non-engineering side of data science. Then, of course, what do you call as the medical management? There are a lot of medical databases where they are hiring. Recently, I saw an advertisement by Apollo Hospital in Chennai. They're looking for data science scientists. Okay, so there are multiple verticals where people can work. Now, just a second, just give me a second. Just a second. Just put my just. Hmm. So I'll show you a few examples here. LinkedIn. So I stay connected on my LinkedIn to various. So this lady, for instance, she is a data scientist and she is a PhD too. She has done her PhD from TIFR and then did her postdoc.
Excuse me, sir.
Because
So your screen is not visible.
oh, is it? Just
Yes.
a minute. Just a minute. See if it is visible now. Okay,
It's not visible.
so she is a PhD in computational physics. Now, I can show you there are plenty of people, those who had done mathematical modeling in PhD and gradually transformed into data scientists. Because in the early years when data science was booming, they had hired a lot of PhDs from statistical physics, material science, those who have had experience working on mathematical models, and they were not getting so easily in market data scientists. So they had hired people having good experience in mathematical modeling or statistical modeling, and they gradually rose to the capacity of a data scientist. So there are a lot of examples. Okay, so now all I would tell you is that my purpose of teaching you this, giving you a background to this data science, getting you exposed to what mathematical models are, is not specific to any kind of a particular problem like material science engineering. It is going to be on generic data, because the fundamental or the backbone of any wherever you apply data science AIML is, I hope all of you are following what I'm trying to put up here. I'm trying to say, right?
Yes, sir.
Okay.
Yes, sir.
So as I was telling you, at the core of data science is what we call as the DS or AI ML models. Okay, now to get an understanding about the models, how these models are constructed, you have to have a very sound understanding of statistics and probability. Once you are done with this part, statistics and probability, then you can move on to the next level of understanding how these models are constructed. Okay, so that is what I say at the core of data science AIML is mathematical modeling. Now, if you're thinking from an academic point of view, for people who claim to be working in AIML are essentially working on mathematical models. But when you go to an industry, just not these mathematical models will do. At the periphery, many other expertise are needed. If you have seen advertisements in LinkedIn or maybe Indeed, what they typically, a data scientist, I will just show you. Today I had um, just a minute. Just a minute. sorry, the first day is going to be, it will take a little time. It takes time the first day. Let me understand if this screen is visible. So he's the son of my colleague. Okay, so he has forwarded his son's resume to me asking if because I'm connected with the data science community, data scientists, if I can help his son find some, internships, because these days students talk more on internships. So these are his kind of experience: programming languages, Python, data visualization using Python like Pandas, NumPy, Seaborn. These are all library, machine learning. So these are typically what industries, and then how you handle database. SQL is a tool. Okay, alongside you have to have experience in tools like Excel, Microsoft Excel, Advanced Excel. These are things which are needed for data scientists. So it's not just how good you are at building mathematical model. If you are looking at the broader perspective of data science, there are a lot many things that you have to gradually adopt to. Is that okay? Yes.
Yes, sir.
Yes, sir.
Okay. So my purpose here is to kind of give you a sense of how these statistical models are constructed. So I'm not here to talk about, for example, so these are, some skills that are required for becoming a data scientist. Microsoft Azure, SQL, okay, AWS. There are plenty of things, TensorFlow. Have all of you seen such names popping up in the advertisements, job notifications, etc.?
Yes, sir.
Familiar
A
with
lot
these
of time.
terms? Huh?
A lot of time we have seen this.
Yeah, same. But
Yes.
possibly if you see data science from an academic viewpoint, you will never learn this. Okay, so if you are willing to jump into this data science career, then you must also adopt to these tools and techniques. Okay, because these are all software based. And what is DSAIML model? This is something. So let me tell you, data science, as I was telling you, at the core is mathematical models. But all these things are working in the periphery. Getting my point? So these are some skills that you need in addition to your AIML, data science, algorithm building experience. But these are also important. But without having this core, if you cannot make this core of data science AML modeling strong, then just doing these things will never end you up in a data scientist position. Are you clear with this, what I'm trying to say?
Yes, sir.
Okay. Yeah, all of you, sorry. Anas, you have understood what I meant here?
Yes, sir. I got your point. These are the basics that must be, we must understand the basics, then we can build on with other
Yes,
softwares.
right. So
Otherwise, the software will be of no use when we
exactly.
cannot
So that's exactly.
understand the models. Yes.
So you have to understand the algorithm. So because I keep receiving questions where students start asking, sir, how can we start with Python? Because many people understand that to start a career in data science is to learn Python. Learning Python will make you a Python programmer, not a data scientist. So learning Python is not the bread and butter of a data scientist. Python is a tool. One can say, well, I'll use R. In academic community, do you know, many people use even MATLAB to work on these data science models. So I'll gradually come to why Python has been so popular in the data science community. Why not C, or why not, R? Or in that case, why not MATLAB, C++? There are many other languages. Why Python has been connected to data science? So these all questions will be addressed gradually. Okay, so until now, what I would say, I hope everything is clear to you. This was just a background information on like what is this data science community about, what I'm here to share with you. So again, I'm going to just give you, introduce you to the statistics probability, building models, but these things like Microsoft Azure, SQL, AWS, TensorFlow, Scikit-learn, there are plenty of things, okay? So these are things which you can learn yourself. You can subscribe in any YouTube channel or go and attend some, you know, professional classes. So these things are not that also difficult, but yes, they need skills. Okay, so let me today begin with the subject of probability. So the probability and statistics go hand in hand. And typically in this thing, I'm going to spend a significant time. Without understanding the essence of probability and statistics, there's no point moving on to models. So you can get a feeling about the models only when you have a good understanding of the probability and statistics. Is that okay? So now all that I'm going to talk about is from today or from now is probability. So just to begin with any one of you, can somebody tell me, all of you share your understanding about probability? This is something which you have studied back in high school or even in the first year of engineering. Not in all engineering universities, probability statistics is introduced in the basic engineering mathematics. Some engineering colleges do, many do not. But probability statistics is for sure you have learned in your class 12th or 10th. Okay, so just tell me, what do you understand by probability? Anyone
It's
of,
about
I mean,
prediction. It's about prediction, how one thing goes. Is it works or it is not? Whether chances, how are the chances, trials, events?
no chance. You said chances,
Yes.
chances, right? Okay,
Chances,
Vinod,
trials.
was it Daya or Vinod? Because I can't see the name because I have opened my,
Uh,
who just
Actually,
spoke
my name
out?
is Sai.
Okay, Sai, but why it
Sai.
is appearing as Vinod Kumar?
It is another my brother's laptop.
Okay, okay. So you are Sai Kumar and your brother is
Uh,
Vinod Kumar.
uh,
Okay. Okay. So probability you see as a chance. Okay.
uh,
So fine, chance is a good attempt. Anybody else? Prashant, how will you see probability as? Hello, your voice is not audible.
Yes, sir. Mostly problems of dice like that we see like
Okay. Um,
yeah, as
so
Sai Kumar said, like chances.
okay. Yes, that is exactly what I wanted to understand. So probability, other than mathematics, you also use in when speaking English. He has a higher probability to come at my house today. We hardly use the word probability. We mostly use possibility when speaking in English. Okay, but in that case, we try to relate possibility with probability. But yes, probability is a chance. Okay, and Anas, you perhaps
Yes,
understand what at least probability is.
yes, sir. It's a likelihood of happening an event.
Yeah,
Is
yes,
in simple language, it is probability.
right.
And yeah.
Likelihood. So you have used the word likelihood. Okay. Now, likelihood has, okay, in simple terms, you can say likelihood, but when I'll gradually move to deep into probability, the likelihood meaning is a little different from what you understand as probability. So, but yes, it is the likelihood of an event to occur. Likelihood of an event to occur. I'll start with a very very common case. For example, many of you have experienced when starting from home, today you know that I have a high possibility of getting trapped, stranded in a traffic jam to reach my office or college. And it happens that that same day when you are thinking that you will be trapped or stranded in a traffic jam, it really happens that you got trapped. So today when coming from office, I somehow intuited that today I'm going to get my road free. Okay, I won't be caught up in any traffic signals. And truly it happened that I could reach home on time. Okay, so can anybody tell me here, or are you understanding my point? All of you are getting मैं चाहूँ तो मैं हिंदी में भी बोल सकता हूँ. It's like कि मैं जो सोचता हूँ वो सचमुच होता है. कई बार Sai, you are okay with Hindi, right?
Somewhat, sir. Somewhat.
Sorry?
Somewhat I know.
Okay, okay, no issues,
Okay.
but I'll again repeat in English. So,
Okay.
so ये ऐसे है कि मैं कभी कभी सोचता हूँ और वही होता है. आज मैं सोचता हूँ कि मेरे घर में मेड आने वाली नहीं है और सचमुच मैं देखा हूँ कि हाँ वो आई नहीं है. So what I'm trying to mean here, Sai, is many times we think that this event is going to happen, be it getting stranded in a traffic jam or absence of your maid, okay? And it truly happens. Okay, if you think this is not going to happen, it doesn't happen. And if you think this is going to happen, it happens. This is what we call as the intuition. Don't you say, I have a sense, I have a sixth sense, which tells me that this is going to very likely happen. Are all of you understanding what I'm trying to say here?
Yes, sir.
सब कोई समझ रहा है?
Yes, sir.
Okay. Why do you think this happens? This is something you have possibly experienced right from your childhood. कि सोचता हूं और वो होता है. और उसी चीज को intuition, we call this as an intuition. What I think it happens in most cases. And why does it happen? Can anybody tell me? Make an attempt.
So might be because by analyzing the situation around us, we can predict that it might happen or not.
Okay, you have to speak a bit louder because somehow I'm not using my headphone today. I think I have to get in my office. So I think you were on the right track. Can you just repeat once again?
So it's might be because we analyze our situation around and we predict something that it will be happening or not. So,
Yeah, but what is that? How are you analyzing that situation? On what basis? Yes, you you're right, going
So some
to
past
some ex-
experience also, like
yes,
sometimes we see that that doesn't
right,
happen, so we gain the experience on the basis
right,
that we make our outcomes.
right. So the past experience gets stored as data in your at the back of your mind. Okay. So
Some
you
sir,
are
there are some key parameters also that we have in mind, such as time. So we
right.
have idea about the time that in the morning time when will be the more traffic, when will be the lesser traffic. So we get some
Days,
intuition
which are
based on some
Monday,
days. Yeah,
Friday,
yeah,
okay, season, rainy season.
season.
So,
Mhm.
and then importantly, that data has to be long enough. I mean, large enough, not long enough. So I can make such prediction about getting trapped in a traffic jam, provided I have traveled in that route for last 3 years, 4 years. Just in a month, traveling for 1 month, say suppose I join my new office, which is in a completely different route, and I've just traveled for 1 month. Okay. Can I make such predictions? Not really. I can't make those predictions. It happens when the system get used, you get used to the system. That means you have kind of the data stored at the back of the mind. And what are you trying to plot from that data? Can anybody tell me here? There is something that is instigating that intuition. What is that thing in that data that is kind of giving you that message or the intuition? डेटा में तो कुछ है जो मुझे वो काइंड ऑफ संकेत दे रहा है, सिग्नल दे रहा है, from where I am making this prediction.
But it is in the subconscious mind that data stored creates patterns which we used to based on the surroundings we used to analyze we used to visualize those patterns, and on that
Right,
we have some intuitions that
right,
this is probably going to happen.
exactly. So from the data, what is going into your head is a pattern. Now, all of you are possibly, I hope, those who have some bit of experience in handling data, you have heard this word pattern. Daya,
Yes, sir.
Sai, Prashant,
Yes, sir. Yes.
yeah,
Yes,
so
sir.
pattern milna chahiye. So this is the pattern. Pattern means a trend. There has to be a trend in the data. So data is a big thing. From there has to be some trend. And this trend can be expressed mathematically. Okay. And this process of capturing that pattern in a mathematical way through a statistical approach based on certain postulates, theories, equations, etc., are all what is constituted in a model. Is that clear?
Yes, sir.
Ritvik boss, this is a very important point. Can you just elaborate and in a simple
No, that
language?
I'll come to that. So this
Okay.
is you are anyway going to have this recording, but possibly at this point, I'm just touching upon, but you will gradually yourself understand why this pattern or how this pattern is getting translated. So my idea of building mathematical model is to capture that pattern. Okay,
Okay.
for making that prediction. Abhi jo, what I was telling you about this intuition is nothing but you are making a prediction.
Yeah.
That prediction, what you are making, or the intuition that you have in mind, is because your brain is working. It is so your brain has that intelligence to work itself on the pattern to give you that message, that signal. And we are simulating that intelligence of the brain through the mathematical governing models. And that is why we call it as artificial intelligence. Now, can you relate the two words?
Yes, sir.
Yes, sir.
Makes sense? And it also possibly makes sense to you why at the core of AI ML data science is mathematical modeling. So mathematical modeling, statistical modeling is the essence of any data science AI ML. Okay. So that was what I was trying to tell you, probability. Now, probability is, as I was saying you, is the likelihood or the chance that an event, probability is equal to the likelihood or chance an event to happen. So likelihood could be, what is my likelihood that I get stuck in a traffic jam today when returning from office? What is my likelihood or the chance that my maid lady will not turn up today? So these are all chances that you are trying to intuit, that you are trying to predict. And you can do it when you have data. Now, this is something I must mention that you won't find in many textbooks. This is something when you start working over and over, you will yourself realize that there are many different variants of probability. So this is again something which has been coined by me. I have formulated these things. Probability are based on, or probability I can classify into the following. Number one, predictions from historical data. So what is this prediction from historical data? Say, to give you an example of the traffic jam. So I have past data for the last 5 years on what day, which month, how much time it took me at the signal. Okay, what was the traffic density at that point of time? What condition of road was at that point of time? If there were many potholes or construction going on, okay, so things will not move or vehicles will not move so fast. So all those parameters, you can say, or the informations are available to me in the form of a data. And data comes when you have a data. If you want to have a nice layout of data, all that you have columns and then you have rows, right? So columns are different, what you call as variables. Okay, so let me give you an example with the traffic jam. I have a data which looks something like this. Year, say 2017 or 2020, that was a COVID year. Okay. Say signal time. This is your data. You have acquired this data. Okay. Then the month. Sorry. Then you can have, say, condition of road. My handwriting is not that good, but if required, I'll just move on to the next slide to write these things. Will give you a more better. So this is typically the data I'm talking about, the road data, year, month, condition of roads, waiting time, at signal, traffic density, so some of these may be categorical type data, some of these could be numerical type data, like condition of road is a good, bad. So these are all categorical type data. Okay. Waiting time at signal, say 10 minutes, is a numerical kind of data. 23 minutes. Traffic density is also, again, a numerical form of data. So these are called historical data. It comes as a number of columns, which we call as a variable, then number of rows. So there are probabilities which we designate or which we calculate based on historical data. Whether it will rain today or not, for that, how can you make those predictions? You have to have the historical data of today's date, which is, say, 9th of November 2023. So you have to have at least 10 years of data of 9th of November. From that data, you can make some forecasting. Okay, what is the possibility or probability that it will rain today? So there are other parameters also too. But what I'm trying to say here is the probability where you hear the probability of whether it will rain or not rain, whether my maid will come or not come. Those probabilities are based on historical events. Just let me understand if you are understanding this particular point, what I'm trying to say to all of you. Yes, please.
Yes, sir. I understand.
Daya, Prashant, Anas, and Sai.
Yes, sir.
Yes, sir.
Yes, sir.
Got it.
So,
Okay. So these probabilities are based on, as I say, on some historical events that has occurred in the past. Then there are probabilities which are not historical events. They are based on a given condition. Like the conditions are known. For example, a dice has 6 faces. Okay. Or a coin has 2 faces, head or the tail. So here, these are known to you. Dice, it will have 6 faces. And there are events such as throwing a dice or tossing a coin or pulling a card from the deck. So card case is also known. There are 52 cards wherein you select a card. So within the state condition, you are doing some operation. Operation could be throwing a dice, tossing a coin, pulling a deck of card. Okay. And those things are within, you can say, within the boundaries. The known conditions are the boundaries. These are the limits. Okay. So I can't give any particular name to it, but I'm trying to say, say you toss a coin, okay, or throw a dice. Do you really require any historical data to understand the probability of getting a head or say 3 on the dice? Do you need any historical data?
no, sir.
No.
It is not based on historical data. Okay, so these are also events which work within the limits, given set of limits, conditions. And then there is another kind of probability, which I call as a proportion probability. I'll tell you what is this. So proportion probability is, say there are 10 people, 10 people, of whom 7 are men and 3 are women. Say they are inside a room. You are an external person. Okay. You want to randomly select somebody from the room. There are 7 men and 3 women outside. So in this case, just try to understand. If I ask what is the probability, or I would put it, instead of saying probability, I'll use the word chance. What is the chance that if I close my eyes and randomly, blindly choose one person from that room, that person will be a lady? So just forget about mathematics, just focus on English language or Hindi language. So who are the majority in this case?
Men.
Men. Women are less. So what is your blind intuition talks? Like suppose if you want to randomly choose somebody from that group, आपके नसीब में कौन किसका आना ज्यादा पॉसिबल है?
Men.
आपके हाँ?
Men.
Yeah. So obviously the probability of getting a man is more than a woman. Okay. So what is that probability? I have to index that probability in some numeric parameter. Okay. So that probability of having a man or a woman would be 3/10. And having the men is 7/10, meaning having a man is always higher than having a woman. Okay. So why I say proportion probability? The reason being here both proportion and probability works together. So if I say, suppose, put the question this way, forget about probability, for example. There are 10 people, 7 are men, 3 are women. I can ask Prashant, what is the proportion of men in this group? Prashant will say, it is 7 out of 10. So in this case, proportion of men is equal to 7/10. Now I ask Sai, if I randomly choose one person from that group, what is the probability that he will turn into, he will be a man? So this time I'm saying probability of that person to be a man. What is the answer? It is also 7/10. Now, can you see in situations like this, where there are 2 or more groups, where there is a ratio between the members in that group, or there is a proportion relationship of the members in that group. In those cases, an event such as choosing somebody randomly from that group will be equal to the probability. Did you understand what I'm trying to say here? Hello?
Yes, sir.
Okay. Daya, Prashant, and Sai.
Sir, can you please repeat last part? Last part I didn't get.
Okay. Okay. Daya and Sai, are you clear with what I said?
No, sir, having doubts.
Yes,
Okay.
sir. But how they are equals?
Okay. So the first 2 things are clear to you, historical events and the conditions
Yes,
where
sir. But those two are clear, sir.
these 2 things are clear to
Yes.
you?
Yes, sir.
Clear, sir.
So you have some doubt with this proportion probability. So proportion probability is something, a term coined by me. You won't see this in this way of classifying the different probabilities is also not so commonly found in books. Okay, this is just for the sake of understanding. The proportion probability arise in situations like where you have to choose an object. Hear me out here. You have to choose an object or an entity from a large group. That is when the proportion probability comes. So I gave an example of few men and women in a group. So one that you know, the proportion of the men is 7/10 and women are 3/10. So if somebody asks you, what is the proportion of men? Your answer will be 7/10. And what is the proportion of women? That will be 3/10. But if the question is put this way, what is the probability? Now, I'm not using the word proportion anymore. First time I have proportion is something which all of you know. What is a proportion? Kitna fraction hai? Yeah, kitna part hai uska? So so now my purpose is different. So the purpose is asking someone, what is the probability? What is the chance that if I randomly choose a person from that group, that person will be a man? The answer is 7/10. And what is the proportion of man? It is also 7/10. So in situations like this, where you have multiple entities and there are some groups of these entities in a larger group, okay, say, to give an, I'll show you with this. I have a pen stand. I have two highlighters, say 4 blue pens, few black pens. Now let me count. 1, 2, 3, 4, 5, 6. Okay. 3 plus 3, 6 plus 3, 9 plus 3, 12 plus 3, 15 plus 4, 19. So I have total of 19 pens. Is it visible to you? I have total of 19 pens, of which 2 are my highlighters. Getting the point? Now, just see it. I can ask Prashant. Prashant, can you tell me, looking at this pen, what is the proportion of highlighter in this entire bunch of pens? So answer will be 2 highlighters out of my 19 pens. That means 2/19.
19.
Is that clear? I did not
Yes, sir.
ask about the probability at all. It's only simply asking about the proportion. But now, for instance, I ask Daya. Daya, if I close my eyes and randomly choose one of the pens, what is the probability that it will be affected? So out of this pen, how many highlighters are there? Only 2. Okay. Isn't it very clear to you that need of choosing a highlighter will be very less? Okay, sorry. I'm not saying I'll just move around and feel, oh, this is my highlighter. Randomly, अगर मैं choose करता हूँ, the point is having the highlighter in this large bunch of pens is going to be very less. And what is the probability of getting the highlighter? It is also 2/19. So 2/19 tells me both things. 2/19 is the proportion of highlighter in my entire pen set, and 2/19 is the probability of drawing a pen which turns to be a highlighter. Is it making sense to you?
Yes, sir.
Yes, sir.
Yes, sir.
Completely clear?
Yes, sir.
Yes, sir.
So that is why I call this as a proportional probability. Okay, now let's move to the next thing. Just a minute. Don't use code. So the very important thing that I often start when starting with probability is to give you introduced to a sample space, or what I call as the sample space. You'll gradually get to know about this space more when I dive a little deep into this. So what is a sample space? Sample space means what are the total number of outcomes or events possible? Let's start with the dice. I'll give you today some examples of sample sets from many different things. Okay, so a dice typically has this kind of thing. Okay, then 4, 5, 6. So if I throw a dice, for instance, what are the all possible outcomes that are possible to come? A 1 can come, a 2 can come, 3, 4, 5, 6. So all these 6 faces where you have these numbers 1 appearing, 2 appearing, 3, 4, 5, 6 are called as the all possible outcomes. So my sample space in this case will be one, 2, 3, 4, 5, 6. That's my sample space. Okay. So if you have thrown the dice, say, or dice 2 times, so there will be 2 1s, 2 2, 2 3s. Okay, so these are all known possible outcomes. So throwing a dice will give me these outcomes. Now coming to flipping a coin or tossing a coin, head and then tail. So what are the possible outcomes? Can you tell me?
2 outcomes, head or tail.
Head or tail.
So that makes my sample space. So if you have tossed a coin, say 10 times, then there will be 10 head, 10 tails. So these are all the possible outcomes that can form as a consequence of an event happening. Okay, now let us give another example. Now think on this. I have a dice and I have a coin. I flip a coin and throw a dice. What could be the possible outcomes? This is my sample space. Yes, Daya, can you tell me what are the possible outcomes? I have thrown a dice and also thrown a coin.
So 1, 2, 3, 4, 5, 6, and head and tail.
Good. You all agree? Okay. This is one way of representing the sample space when it is, say, a 2 event. Okay. But we can also represent this in the following way. Now, it depends on what is the outcome that you are studying. If I frame a question as to finding a probability that when I throw a dice and flip a coin both together, what is the probability that I will have an even number on the dice and a tail on the coin? Getting my question? So I want two things to happen simultaneously. Getting an even number on the dice and a tail on the coin. Both to happen simultaneously, then it gives me a sense that I should not think separately 1, 2, 3, 4, 5, 6 head and tail. I should think in pair. So what can be the pairs? So oftentimes we draw a matrix. Okay. Just a minute. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I have here head and tail. So what are the possibilities that you can expect? Just you do this way. I'll write H1, H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. So my sample space will kind of reduce to H1, H3, H2, H4, T1, T3, T4, T5, H5, T6, H6. So they are coming as pairs. Makes sense to all of you? Hello? Is there a lag in my voice? Because when I'm asking, I'm getting the reply after a few seconds. Hello?
Yes, sir, clear, sir.
Yes, sir.
But I'm getting possibly the response a little delayed. So it's clear to all of you. Okay. Any question on this? If you have, you can ask me.
Sir, I have a question. When we talk in terms of the pair, so how we form the pair here in this space?
How we form the pair means, can you just repeat it?
Sir, we talk about a pair formation in the space. So how
Right.
we have a pair in this pair?
So how we are forming that pair?
Uh-huh.
So that's how I'm saying that I'm throwing a dice and tossing a coin together. What are the all possible combinations can happen? So you can get one head and a number 1, one tail and a number 5, one head, a number 3. So what are these all possible combinations
Right,
that
right.
can, getting my point?
And yes, sir, understand. Yes.
So I guess, Prashant, you possibly uh, got a little absent-minded in between, because this is a very straight thing. Okay, so you are making two things to happen simultaneously. All that you have to see, what is my objective? Okay, based on the objective, you have to decide the sample space. I'll just enumerate this point more. If I say, suppose you have a dice and a coin, both you are flipping together. You ask me, what is the probability of having an even number of dice? What are the even numbers in a dice? 2, 4, and 6. So in that case, if I represent my sample space as these pairs, it will make no sense. in such case, I can represent my sample space in this way. Don't keep these pairs 1, 2, 3, 4. So all these are my possible outcomes. An individual 1, an individual 2, an individual 3, an individual head, and individual tail. Because at this point of time, my question is to find the probability that I have an even number of dice. That is, the face that is facing must have an even number. What is that probability? I've not talked about the coin. Okay. So in this case, possibly this pair thing will not give any sense. So you can keep the sample space, show each of these elements individually. There is no point to pair, but I'll possibly pair it in this situation where I ask this thing to happen and that thing to happen, meaning that I want, say, a even number on my dice and a tail in my coin, both to happen simultaneously. So therefore, the question, how it is framed, based on that, my sample space will be defined. Because in this particular question was, my dice must show a even number, that is with the dice. And at the same time, I'm saying my coin should show a tail. So I want, when throwing both the dice together, both coin and the dice together, the number which is even and the face which is tail to appear simultaneously. So to do that, I need the space to be organized that is in line with the question that is being asked. And I can do it only if I pair this. Is it kind of understood to people present here?
Yes, sir.
Yes, sir. Yes.
Okay, so it's not very rocket science. You will gradually get to know. It's जैसे जैसे हम problems कुछ करेंगे आपको पता चलेगा. So this part is, I guess, is clear to you. Now, sorry. I ask you a question. There are 7 men. Seven men and 3 women. Okay, they're in a house, in a room. I ask, say Anas, randomly choose a person from that group of 7 men and 3 women. Okay, and give a, whomever you choose, give a coin to that person. That's a statement. Anas has to choose a person randomly from that group, and whoever he chooses, he has to give a coin to that person. Now the question is, if Anas does that, what is that probability that Anas choose a man from that group, and that man, when he tosses the coin, he gets a head? Is the question clear to you? So there are 2 activities to be done. One is Anas choosing a person, and then the second is asking that person to toss a coin. Okay, so Anas choosing a person, what is that probability? And I mean, Anas choosing a person and that person is a man. What is that probability? There.
So 7 by 10, sir.
Yes. And now Anas gives a coin to that person. What is asked is that he gets, that person, when he tosses the coin, he gets a head. What is the probability that that same person, that man, now that he is a man and he tosses a coin and he gets a head? So what is the probability of getting a head?
1 by 2, sir.
1 by 2. So now you just think, if it was simply, if I had Anas to choose a person and ask him what is the probability that if you choose a person will be a man, he would have said 7 by 10. But now I am also imposing another condition, that this person, when he tosses a coin, must also get a head. So आप अभी सोचो, isn't it getting more and more constrained? I mean, you are asking something like that. Patiently hear me.
That means probability is reducing.
Yeah, sorry?
That means probability is reducing.
Yes.
The
So
value
how
of
will it reduce? Just so I always tell students, forget about the mathematics part. Just think it rationally from your own sense. What is the probability that what is the probability that tomorrow my maid will come? Okay. And then I ask, what is the probability that my maid will come and then that she will wear a red sari? Which probability looks to be more to you? The probability of your maid coming or your probability of your maid coming and wearing a red sari? Which probability you think is more?
coming.
Coming.
Yeah, maid coming.
Maid coming.
So now that you have understood, that means if you're imposing restrictions, so wearing a red sari is a kind of a constraint. Similarly, asking that person to toss a coin is a kind of a constraint that is imposed. When you have a probability of an event upon which there is also another probabilistic event taking place, then there are two things that has to occur simultaneously. That probability will reduce. And that will reduce in the order of the product of the two probabilities. That means choosing a person from that group of 10 people is that person's probability to be a man, and then tossing a coin, getting a head, means that 7 by 10 has to be multiplied with half. That means 7 by 10, which is the probability of choosing a man, and then you have another half, which will give me 7 by 20. That means my probability has reduced from 7 by 10 to 7 by 20. So the question oftentimes arises. I'm sorry, I have a very bad cough. Now can you understand, you had a confusion back during your school days or during college days कि सर मैं probability में add करूंगा दो event या multiply करूंगा? Was this a question to you back during your college days? Add करना है कब, multiply कब करना है? When to add, when to multiply? Did such questions ever arise in your mind?
Yes, sir.
yes, sir.
So multiplication comes when there is, you see, the chance is reducing. So why multiplication? Because multiplication can only give you that reduction. If you add that, it will increase the possibility. 7 by 10, if you had added to half, that means you have got 12 by, say 12 by 10, which is more than one probability. which is absurd. So you cannot think of even adding. I'll come to addition case later, but this multiplication can only shrink the possibility of the chance. There is no other way, because this multiplication, because probability of any event is between 0 and 1. So you get a decimal figure, 0.x, xx or something, okay? So when you are multiplying 0.xx, okay, product with say 0.yy, only then this, when you multiply 2 with 3, the product is always greater, okay? But when you are multiplying between two fractions, decimals, the product is always smaller. 0.4 multiplied to 0.5, what is the answer? 0.2. It's always smaller. So that means when you multiply the two probability events, you will get a smaller value for the probability, meaning that your probability is going to reduce. Is this part clear?
Yes, sir.
Complete? Okay. Now I tell the following thing. So again, I'm asking, I have this habit of asking everyone. So all of you are clear with when to multiply?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Now let me tell you, there is nothing in probability called as a subtraction rule. There are only two rules that rule the probability. One is multiplication and the other is addition. Okay. Now let me also tell you about the addition thing, when to add something. Suppose in the same question, if I had asked, say, let me frame it. Okay, let me frame it this way. Okay, now Daya choose a person and he asked that person to toss a coin. Now I, as an external observer, I'll frame a question. What is the probability that Daya choose a person can be either man or woman, or forget this. What is the probability that Daya choose a person is a man, or when that person tosses the coin, he gets a head? Think on this point. I'm kind of given a relaxation to Daya, saying, Daya, what is the probability that the person you choose? Okay, this question is not fitting in this particular case. Let me think of another question. I mean, then it will make you, this will make it more complicated. I'm thinking of another question where this addition rule goes straight. Let us take a dice. I ask a question, what is the probability that I get a 2 or an even number? Or if I throw a dice, let me rephrase the question. I get a 3 or an even number. Okay. इन दोनों में से कोई एक होगा तो चलेगा. उसका क्या probability? So I have no restrictions here. So suppose I'm throwing a dice. What is the probability that I get a 3 on the dice? Let me go to this next figure. Let me draw a dice. Is my screen visible? Okay. Then is this clear? Okay. So if I throw a dice, I get a 3, getting 3. What is that probability? Can anybody say?
1 by
1 by
6.
6.
1 by 6. Getting a 3. And what is the probability that I get an even number?
1 by 2.
Do you
So
all
1 by
agree?
6.
Huh?
1 by 6.
Why 1 by 6?
So 1 by 2. It will be 3 by 6. Sir.
So there are,
Oh,
yeah. So in this particular case, getting a even number is much high. वो कोई ना कोई तो होगा, 2 भी हो सकता है, 4 भी हो सकता है, 6 भी हो सकता है. That means just think it that way. I told you, forget about the mathematics. Think it a very practical, rational point. So when I'm asking to throw a dice on which you will get 1 or get a 3, 3 is only 1. Getting only 8 3 मिलना बहुत difficult हो सकता है 6 एक toss में. But if I'm giving you kind of option, like कोई भी even number, any even number will do. It can be 2, 4, 6. Are
3 by
you feeling that constraint anymore?
no.
No, you're more free. So that
Yeah.
means your probability chance of getting any of these 3 even numbers is much higher than getting a one single number, say 3. Okay, so first see, is that my probability going to increase or decrease? Think from that point. Then you think about addition, multiplication, and the following things. Okay, so getting an even number is 3 by 6. I'll come to how these fractions are decided. But now from your basic understanding, you also know it is going to be 3 by 6, which is half. Okay, sorry. Is this clear? This is going to be my half. So half is obviously higher probability. That means getting an even number has a much higher probability than getting a single 3. Is this clear to all of you? Okay.
Yes, sir.
Now my question is,
Yes, sir.
my question was, I throw a dice, I get either a 3 or an even number. Is it a much constrained case? Are you feeling constrained, or it's a very open, like you are increasing the possibility? Is that my question clear? Like in the previous case, I had put a constraint on your question that the person whom you select has to be a man and he has to get a head. But in this case, am I giving you that relaxation or putting you in a burden?
So relaxation.
Relaxation.
Relax.
So relaxation means addition. You must think from that point. So what I'll do is, in this case, 1 by 6 is the probability that I get a 3. Okay. And half is the possible probability that I get an even number. So I can have this or that. Okay. Any of these two will give me that pleasure, you can say. So in this case, I can increase, I have to go to a more increasing thing. The question is, should I multiply or should I add? So the answer is we have to add. 1/6 plus 1/2 only can give me that probability of increasing that chance. So because it's more of a relaxed case, it's no more constraint. So we can only, it can happen if we add the two together. It cannot follow the multiplication rule. Does it make sense to you, to all of you?
Yes, sir.
Yes, sir.
Okay. Now, there are some cases. Now, I'll start with something called as a very popular thing which you have all studied back in your high school, which we call as the Venn diagram. Very popular school time mathematics picture which you have seen. This is the Venn diagram. अभी मैं आपको बता रहा हूँ. You have seen all these things, right? Can you tell me what is this rectangle representing?
Sample space.
Yes, that is my sample space, which I have introduced you to showing these things. That's exactly my sample space. Okay. Now, what are these circles representing? See, let me tell you, these circles doesn't mean that they can be of any size. The measurement of the circle depends on the probability of that event. If suppose, just a minute. I'm representing two events, say this and this. I call this as event A and this as event B, meaning that the probability of the event A taking place is less than the probability of event B. So A is less than B. So it is represented by a small circle and a big circle. Okay. Now let me start with one or two examples. It will be more clear to you. Now the question is, ये diagrams तो आपने पहले भी बनाया. What is that inside these circles? What is the outside these circles? Okay. Now, for example, I'm throwing a dice. So when I'm say throwing a dice, what can the most easy outcomes be? My outcomes will be in the sample space. It could be 1, 2, 3, 4, 5, 6. Okay. Now, this is my sample space. And I ask, what is the probability that I'm throwing a dice? So all these 1, 2, 3, 4, 5, 6 are the known possible outcomes of an experiment when throwing that dice. That experiment is throwing a dice. Eight dice, so experiment with two dice is different, one dice is different. So when I throw a single dice, that it will have, what are the possible outcomes? The possible outcomes are these numbers. So the result of throwing a dice is getting a number, isn't it? Ab dice se kya dekhte ho? Like even when playing a Ludo, which number is facing towards on the top? So that is an outcome. So the all possible outcomes that can eventually result as a consequence of throwing a dice are these all these 6 numbers. Is that clear? Now my question is, what is the probability that I get an even number? So question is, what is the probability I get an even number? So what are the even numbers here?
2, 4, 6.
Even numbers are 2, 4, and 6. Okay. So what I typically try to do here is I'll put this 2, 4, 6 in a circle. to represent that these are my even numbers. So moving to the other figure, I'll show you to make it more clear. You hear the recording carefully, okay? So this circle represent, say, I call this circle as event A. And what is A? Having an even number. Having an even number. So what I have done is, from the known possible outcomes, I have taken out those outcomes which corresponds to even number. Which were those? 2, 4, 6, and put them in a circle. I call that circle as event A. Is that okay? So that goes event A. Now, I say, what is the probability that I get an odd number? So what are the odd numbers here? This is 1, 3, and say this way, I've represented 5 with a green shaded region. So that's okay. Is that clear? Yes, please tell me if it is clear up till
Yes,
now.
sir.
Yes, sir.
Yes, sir. Yes.
Now you think, I am asking this away. The two events A and B. Event A is event B is equal to odd number. When throwing a dice, can both the event occur together? Meaning, if I throw a dice, okay, can even A and even B, it is mostly understood event A in most cases will not hinder event B. But are there common cases also? The answer is no. If you are getting an even number, you cannot get an odd number. If you're getting an odd number, you can't get an even number. So the two events are not going to intersect at all to each other. Similarly, like if you are getting a head, you can't get a tail. If you get a tail, you can't get a head. So none of these two events are linked or interrelated to each other. Getting a head has nothing to do with, there is nothing in common. So those kind of events where they do not kind of overlap over each other, we call these events as mutually exclusive events. Have you heard about, this term before?
Yes, sir.
So these are called as the mutually exclusive events. All of you are getting this point. So what is then a common event? Then you can understand, then you can make a distinction. Suppose I take, so all of you know the game of card, the Tash, you know, all of you?
Yes. Yes,
Prashant,
sir.
Daya, Mohammed, Anas, and Sai.
Yes,
Yes,
sir.
sir.
So there are a total of 52 cards. Okay, let me move on to the next slide, then you can understand possibly better. Okay, so in cards, you have total of 52. So there are two things, there are few things. One is the color. Color I'll show you. One of the color. Red colors corresponds to this heart and diamond. Okay, and then the black color corresponds to, what is that other thing? Spade. Okay, so how many red colors are there in total? What is the total number of red colors? I'm not asking about diamond and heart. What is the total number of red colors?
26.
Yes. So 26 are red, and then the other 26 are black. Okay. Now, what could be the sample space if I say I want to create a sample space for cards? Can just anybody guess what is the simplest sample space that you can? जैसे dice के case में simple dice 1, 2, 3, 4, 5, 6 constitutes the sample space of dice thrown only once. What could, just give me a blind guess, what is typically going to be the sample space for cards? So I'll tell you, the sample space for cards, the most easiest ways you can think is the cards itself. Pura cards ko like you fella do. So you have color and number together and the characteristic, which is a spade. So there are two things. One, in a card, there are three characteristics. Okay. One is the number. Number ranges from A to then king, queen, 2, 3, all these things come to, I think 10, right? Okay. Then the other thing is color, which is red and black. So any number and special cards like king, queen, jack, and A, everything is 4. There will be 4 3s, there will be 4 5s, there will be 4 10s, and so on. And then there will be 2 set of color. Okay. So is up to this point, this is clear. So these are the characteristics. The number is a characteristic, the color is a characteristic. Now, in the sample space of cards, yes, you can think of the numbers separately and the characteristics like color as a separate thing. Okay, but usually you don't have to think of in such a complicated way. So in case of cards, you can simply think all the cards are laid in that rectangle. Okay. Now, so sample space here is that not important. It is just to give you a fair idea about how we are drawing these circles. Now, I give a question saying that what is the probability of choosing a red color? Okay, that is the event A. I'm calling that event of choosing a red color as A. So I'll represent this with a circle, which I call as the event A, where A is choosing a red color. Which red, I don't know. It could be king red, 5 red, 5 diamond red, because diamond and hearts are both red. It can be anything, but the color has to be red. Okay. So can somebody tell me what is that probability of finding anything from a deck of card? I have this, my card, and I pull something, and that comes to be red color. Does it have, first ask yourself, will it be a high probability? मतलब मैं अगर पूछता था किंग निकालो, उसका क्या probability, और एक red color निकालो, which one gives me the higher probability, finding a red one or finding a king?
Finding a red one.
Red.
That will give me a higher probability. So I call that event A as choosing a red color. And the event B is choosing a black color. Now tell me, are they mutually exclusive or not?
So mutually exclusive.
Truly
Yes,
exclusive.
because if you're choosing red, you can't have a black in it. Red means is a red. Okay. But if I say, if I say what is the probability that you have a red color? And then again, I have to say, what is the probability that you have a king? Can these two probability events have a overlap? Yes, they can. So answer to that is a king red, which could be a king diamond, for example. So there are 4 kings, 2 black and 2 red. Red of the heart and the diamond. Okay. So if A is an event, which is choosing a red, and then if I have another event, which I say B is an event choosing a king, can these two events simultaneously also happen? It may not happen most of the time, but are there cases where there can be a simultaneous occurrence of both? Ki king bhi ho or red bhi ho?
Yes, sir. There are some.
Possible.
So at the same time, can 2 events occur? That was the question. The answer is yes. A king diamond can come, a king heart can come, they're also red. So that event, which I say as B, which is choosing a king, will actually overlap with my, sorry, I'll just make a correction here. I cannot show with the same circle. So my idea will be, because choosing a king has a lesser probability, I have to show that with a smaller circle. Make sense? So there are, what do you say, some overlapping region. And what is that overlapping region? It is this region. What does that region say? Those cases where it will be both king and a red. And in this case, which are the 2 things? So what are this red circle? Question will obviously arise. What does this red circle constitute inside it? So what is a red? Choosing a red. So red circle will constitute those points which are all red. 2 hearts, 5 diamonds, 7 hearts. Getting my point? So all these points represent a red color. Okay, it could be A heart, A diamond, king heart, king diamond, 2 diamond, 2 hearts. Everything that is red will be included there. And then this set will have those points which represents king. It will be king of heart, king of diamond, king of spade, king of club. Okay. So what is then this overlap representing? So this overlap is representing what are the 2 cases where it will be both king and also red color in a single attempt. मतलब मैं अगर खेलता हूं, if I play, it will satisfy both the events. That is what is meant here. So that will be represented by this small intersection area, which is called as the union of event A and event B. Getting the point? So this is my event B. So A, sorry. So this region that represents both the event, remember I clearly mentioned the word same time together. If both the event has to occur in the same time. See, in the case of head and tail, both cannot happen at the same time. If it is head, it is head. If it is tail, it is only tail. Similarly, throwing a dice, getting a 1, for example, or getting a 3. If you get a 3, you cannot get a 5 or 6 or 1. Okay. So in those cases, everything is mutually exclusive. They are not going to, 2 events are not going to kind of have a common overlap. But in case of the drawing a card from the deck of 52 cards, you can have two events which can superimpose or which can overlap with each other. Which kind of cases? Cases like this. A, which is choosing a red, B, which is choosing a king. Okay, because you can have a king red also, which could be king diamond, king. So this area, represents my king diamond, and I mean, these are the two things which can happen. So in this small area, only two dots will be represented. Getting the point? One is this dot and the other is this dot, which represents king of diamond and king of hearts. So that common area, that intersection area, is not a kind of continuous area. It is just a representation to show what are the possible point or states that can be enclosed within that, I mean, area. That is all that it says. Okay. So is it clear to all of you? What is this case? This is a case of union, or what we call as these particular events are mutually inclusive. Please let me understand if these two things got clarified, got clear to you.
Clear, sir.
All of you are clear?
Yes, sir.
Okay. But
Yes, sir.
if I had this case, for example, if I had this case, okay. Now let me put this sample space as black. Okay. I want an event which I'm representing as A, choosing a red color as an event, which is A, and choosing a black color, which is event B. Can these two cases be mutually inclusive? No. If it is black, it cannot be red. So in this case, these are mutually exclusive. But in the same cards, you can have a mutually inclusive case also and a mutually exclusive case also. So it all depends on the question that you are designing. Getting the point?
Yes, sir.
Yes, sir.
So similarly, in the case of throwing a dice, you have 1, 3, 2, 4, 5, 6. If I set a question asking, what is the probability of getting any number, say PA? Now I have changed this. My probability of A getting a number greater than 3, and probability of B, or I won't write probability term here. Simply. Okay, A is an event that you throw, get a number greater than 3, and B is an event getting a number which is even. So think this way, getting a number greater than 3. Which are the number greater than 3? 4, 5, 6. Okay, so let me mark these two numbers first. 4, 5, and 6. Okay, and then event B is getting an even number. So what are the even numbers here? I'll mark it this way. An even number is 2, 4, and 6. Isn't it? So what is then? So are these mutually inclusive? Yes, they are mutually inclusive. Understood? because what I'm showing here, you can also represent the same using the circles. I have this red circle, which is my number greater than 3. And then I have this green circle representing, which is an even number. Okay, so this common intersection space, this common intersection space is these two numbers, 4 and 6. So you will have in that common intersection space only two dots, which are representing 4 and 6. So that is how we are representing probability in Venn diagrams. Is it all okay?
Yes, sir.
Yes, sir.
Okay, so this is one thing, and I'll take the last minute to explain, and maybe I'll let you know if tomorrow I have time. I can also ask you to come for a short time, maybe for 1 hour, because day after tomorrow I'm leaving for my hometown for the Diwali vacation. In between, I'll share the video with you. Take your time to understand, digest everything that was taught today, okay, in the probability, so that we can go ahead in our next discussion. Okay, so if this part is clear, then we move on to the next part. Okay, where one event kind of influences the other event. Okay, when I'm saying, just understand, I'm throwing a dice. I'm throwing a dice and I get 2. This is my event number 1 or event A. So event A is I throw a dice and get 2. Event B is I again throw a dice and get again 2. So, for example, I want to see this thing this way. Like there will be 2 tossing. In the first, I must get a 2. In the second, I must again get a 2. Okay, 2 events happenings one after the other. Are these 2 events anyway going to hamper each other, hamper the probability? So that means if the event A has occurred, okay, is it anyway going to influence the event B? The answer is no. Event B is a separate, I mean, it's the same dice, but the game is a different game. The first game is a different game, means throw. First time I threw, I got something. Second time I threw, I got something. Both these getting something has nothing to do with each other. But let me tell you an example of drawing a card. Okay. Now I change the statement to the following. Event, say X is drawing a king. Okay. Then event Y is drawing a black color. Now just see, there's an interesting thing here. In the case of event X, suppose this is my deck of card. What is the probability that I draw a king in the deck of card? Daya, can you tell me?
So 4 by 56.
4 by
56.
what is 56?
Sorry, 52, sir.
Yeah.
Slip
So
of
all of you agree it is 4 by 52? Yes, Sai?
Yes,
Yes.
sir.
Okay. Now, suppose I draw a card and throw that card. Okay. That means I draw a card and keep it with me. I don't put it back into that card deck. So when my next event is going to happen, which is drawing a black, can somebody tell me what is the probability that the black would be drawn?
4 by 48.
4 by
48.
why 48? Or let me make it simple. I'll tell you. I'll tell you. Hold. I won't say black. I would say drawing a queen. So, सबसे पहले, like from the deck of card, I choose a king. I choose something, take out, and put it in my pocket. So, what was the probability that I chose something that was a king? 4 by 52. Okay. Now, after I have put it into my pocket, what is the total number of card now?
51.
51. Okay. So it is when I'm drawing the queen, I'm calculating the probability for queen. My denominator is going to be 51. So the two things to happen together, that is the first draw will give me a king and the second draw will give me a queen, will be actually sorry, will be actually drawing a king is 4 by 52. And then I say multiply to it with 4 by 51. This is 52. You know why I have multiplied? Because there are two conditions have to play. First draw will give me a king and the second draw will give me a queen. Matlab, constraint conditions. So I have to multiply. But can you see my first event is actually influencing my second event?
Yes, sir.
Yes.
So my first game, in the case of throwing a dice, my first dice getting a number is no way going to influence my second effect. But in the case of card, when I'm drawing a card, that first game is going to influence my second game. Okay, so this kind of cases where an event has happened and another event is in pipeline, calculating the probability is what we call as a conditional probability. A condition has happened. We say, given that that situation has taken place, then find the probability. Given that a card was selected, which was a king, what is the probability that you select a queen? Makes sense to you?
Yes, sir.
So
Yes,
when,
sir.
when one event is directly influencing the other event, then this concept of conditional probability comes. It is something like, I'll tell you, I'll just give me 1 minute and then today we'll close the session. It is, suppose there is a teacher in a school. I don't know, wherever you have studied in your young age in some schools, मेरे स्कूल में ऐसे होता था, एक सब्जेक्ट को, I remember those days, they were the same subject, say biology, was taken by two teachers. Monday, Thursday, one teacher, Tuesday, Wednesday, another teacher. So one teacher covers one portion and the other teacher covers another portion. Okay. Has something similar happened in your school days?
Yes, sir.
Okay. It is not in every school, but in many schools they have. Okay. Now, it may happen that one biology teacher is a very interesting teacher. Okay. And the other biology teacher is a very boring person. So take a situation like this, and when the boring teacher comes in the class, it is seen that most students bunk the class. And the interesting teacher comes, most students attend the class. Now, suppose here is a situation. What is, say, this is to kind of give you a more better feeling about this conditional probability. On a specific day, you ask, what is the probability that the boring teacher will come today? And the students will attend the class, something like this. So there are two conditions. Probability that the boring teacher will come today, and if the boring teacher comes, that event has happened, then what is the probability that the students will attend the class? Make sense to you?
Yes, sir.
Yes, sir.
All of you are clear? So one event, boring teachers coming, has to do with the class attendance. So one event, given the condition or given that the boring teacher has come, what is the probability? So first you find out what is the probability of that boring teacher coming in the class. And now, once he has come, now consider that he has come. Okay. First you have calculated the probability of his coming to the class today. That is one part. And now you are saying that the teacher has come. Now you are calculating what is the probability that the students will come in the class. So there are two probabilities. So one precedes the other. Completely clear? So these are called conditional probability. In the same way, drawing a king will hamper the next play, which is the probability of drawing a queen. Okay, so with that today, I'm going to conclude today's presentation. So all I would say is tomorrow I'll see if I can find time. I'll continue with this conditional probability to finish one part. Else, I'll say you just go ahead with whatever I've taught today. And video lecture, I mean, the recording will be available, but be prepared while coming to the next class. Like whatever I have discussed today, and tomorrow also I'll try to take another class. Be prepared so that next class it becomes easy for you, and it is also like I have put so much effort. So you have to also kind of give me a response. Getting my point? So just tell me, how did you feel my teaching is?
Sir, seems very good.
Okay, thank you. And others?
Sir, it was an excellent class. I think I got a lot of clarity while attending it, and the complex things like conditional probability and and mutually inclusive, mutually exclusive. You explained it in such an easy language and with so much ease that it had helped me a lot in understanding the basic concepts, and I'm sure that I can build on these
Okay.
concepts further on. Thank you, sir. Thank you very much.
Okay. And then Dayan Sai?
Yes, sir, it is.
The
It was
way of
really
expressing is nice. Sir. So
Okay.
the way you express is very nice.
Thank you. So I would expect you to, so this recording, I'll just stop sharing. Stop share. and I'll be pausing the recording. So today we are kind of winding up the session. I'll share tonight the video link. Just go through it. And tomorrow, as I said, I'll try to take a class. If not, then go ahead with this recording. We will meet next week. So I'll be back 19th. So 19th we can meet. Okay.
Okay, sir.
So good night then. Thanks for
Okay, sir.
joining me.
Thank you.
Thank you, sir.
Okay.
Thank you. Thank you
Good
very
night,
much.
sir.
Thank you. Thank you.
Good
Thank you.
night, sir.
Goodbye.